Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we're going to continue our lecture on a new topic. Basically, under chapter number 4 is one-way analysis of variance, ANOVA. So, as you can see in page number 153, this is the one-way analysis of variance, ANOVA, SPSS output. So from the SPSS output, we're going to have basically two tables, right? First table is ANOVA itself, and the second table is post-hoc analysis, multiple comparison table. So before we go further, I just want to emphasize that this topic is actually for comparing to find the mean difference of three groups, two or more groups, right? So we want to find, if your objective is to find the mean difference of more than two groups basically, so you can use one-way ANOVA. And the assumption is for ANOVA, X variable means independent variable should be categorical variable with more than two levels. Means if you have male and female, it's not enough to use one-way analysis of variance. You should have more than two levels. Means if you have ethnicity, Malay, Chinese, Indian, then you can use one-way analysis of variance. And Y variable is dependent variable. Dependent variable should be numerical in nature, right? So dependent variable should be numerical in nature, and you want to find the difference of the mean difference of Y between X. X is a categorical variable. You have more than two groups basically. So if you can see, this is the first table is ANOVA table. The ANOVA table is standard in SPSS. First you have between group, within group, and total. And the second column you should have sum of square, right? This is a sum of square for between group, right? Sum of square for between group. And the second one is within group, right? Sum of square within group, and this is sum of square total. Sum of square total means that you're going to add 3,142 and 420, then you're going to get 3,363. And beside sum of square column, you have degree of freedom, right? Degree of freedom, the first degree of freedom indicate the degree of freedom for between group. So you need to know how many group you have, right? If you have, let's say I'm using ethnicity kan, ethnicity, so you have Malay, Chinese, Indian, so I'm going to have three group, right? So three group for the first degree of freedom. So this one should be n minus 1, or basically we're going to call a group as a K. So K should equal to 3 minus 1 should be equal to 2. So K here is our number of group, right? And then within group, the degree of freedom within group is actually number of sample size minus group, number of group. So number of sample size for this one is 80. I don't think 87. 88 should be 88. Number of sample size is 88 minus 3. It should be equal to 85, right? Okay. So the last degree of freedom is the degree of freedom for total. Total means n, the number of sample size minus 1, should be 88 minus 1 equal to 87, right? And the third column for the ANOVA table is mean square. mean square for between group, and mean square for within group. There are no mean square for total. We're going to calculate mean square for within group, within group, and mean square for between group, right? So mean square is a square root of is the division of sum of square divided by degree of freedom, right? So let me clear this one first. We don't have enough space. So let's say if you want to get mean square for between group, right? So sum of square between group, right, divide by degree of freedom for between group, right? So it should be equal to 420.655 divided by 2. So you're going to get 210.327, right? Okay, for the second mean square within group, or we're going to call it in normal time, we're going to call it as a mean square error. It's actually mean square error within group. So the same procedure. We're going to get sum of square within group, right? Or sum of square error, right? Divide by degree of freedom void. So it's going to be 3,142.593 divided by 85. So you're going to get 36.972. So I already give the calculation above the table, right? Are you clear with this one? Right. So the next one is the F value. The F value is actually the ratio between mean square between group divided by mean square within group. Actually, mean square between group, or what we call, or normal time, we're going to call it as mean square treatment. Mean square treatment. Right, let me clear this one. The mean square treatment. Mean square treatment is also called as mean square between group. It's actually main for between group. Right, divide by mean square error. Mean square error is within group. Right. So let me put this one clear. Mean square between group and mean square within group. So you're going to get F value. F is the ratio between mean square between group and mean square within group. So you divide these two values, you're going to get F value, right? And the last column is your P value. This is a P value, right? The red box is P value, right? So the P value is going to indicate whether going to give us the overall picture, whether there is a significant difference between this group or no significant difference, right? So this is the hypothesis testing, hypothesis statement. The null hypothesis is equal to mean for group A equal to for mean group B equal to mean group C. And alternative hypothesis is at least one pair of the mean is not equal, right? And the p-value, if the p-value is less than 0.05, let's say less than our alpha can be any value, right? If the p-value less than our alpha, then we're going to reject null hypothesis. And then we can conclude that at least one pair is different. So which pair is different? We don't know. So if you want to know which pair is different, then you need to proceed with the Posthoc test. Right. Posthoc test, there are a lot of methods in Posthoc test. There are LSD method, Bonferroni method, Tukey method, Chaffee method, and so on. Right. So in this subject, we're going to use LSD multiple comparison for Posthoc test. So the null hypothesis for Posthoc test, this Posthoc test is done when the p-value is less than 0.05 or p-value less than our alpha, or where anywhere you can conclude that the null hypothesis is rejected. So when the null hypothesis is rejected, then you need to proceed with Posthoc test. If the null hypothesis is not rejected, then you know no point to proceed with Posthoc test, right? So in Posthoc test, the null hypothesis is there are no difference between two means. Another one, the alternative hypothesis is there is a difference between two means. Right? We're going to reject a null hypothesis if the p-value is less than 0.05 or less than our alpha. So things to look at the Posthoc test is on the significant value, on the probability value or p-value, right? So this one indicate that the first box indicate that the difference between A and B, the difference between A and C, and the last one, the second box is the difference between B and A, which is same as A and B, and B and C, right? So the last box is repeated as the first one and second one, right? So by looking at the first one, A and B, so we look at like this way. Need to put some line so you can see clearly, right? The mean difference between group A and group B, right? The mean difference is negative 3.97, right? The standard error is 1.708, and this is the p-value 0.022, which is less than 0.05, which is if our alpha is 0.05. So we can say that there is a difference of mean group A and group B, right? Since the p-value is less than 0.05. Same goes to group A and group C. Look at the p-value is less than 0.05, so we can conclude that there is a difference between A and C. B and A is also same as A and B. We don't need to mention it two times, but what we want to focus is on B and C. So we already focus on A and B, A and C. Now we want to proceed with B and C. So look at the B and C. The p-value for B and C is more than 0.05. So we can conclude that there is no difference of mean between group B and group C, right? So basically this is the SPSS output that you need to get familiarized. So you need to remember the purpose of this analysis. What is the purpose? We want to find the difference of mean between groups where the group is more than two level. If you have only two level, you should not proceed with the analysis of variance. You should proceed with independent sample t-test, as we'll discuss on the last lecture, right? So in the final exam, you're going to get this formula given on the back side. So you're going to explain K is the number of different sample or treatment. Basically, K is a number of group lah. N1 is sample size. T is the sum of the value of the sample. N is the number of value in the all sample, right? And degree of freedom for numerator is K minus 1. degree of freedom for denominator is n minus k, and this is the formula for sum of square total, right? And this is sum of square between sample sum of square, which is sum of square between group, and sum of square within group is sum of square total minus sum of square between group. And mean square between group is sum of square between group divided by k minus 1, which is this is a degree of freedom for between group. And same goes to mean square for within group, a sample size, number of sample size divide minus number of group. And to get the value of f is mean square between group divided by mean square within group, right? So before we go to example, I want to show you how to do one-way ANOVA in SPSS. So let's use demo dataset. Can you open demo dataset SPSS and open demo dataset as usual, right? So now in demo dataset, there are a lot of variables, right? We're going to remove some variable and keep only two variables that we want to use for the analysis of variance. And you need to remember, in analysis of variance, the y variable, dependent variable, is numerical variable, and independent variable is a categorical variable with more than two levels. The purpose is we want to find the difference between this group, right? So I'm going to keep only income variable, right, which is this is going to be our independent variable y, and we're going to keep in employment category, right, years in current employer, right? So to do so, I'm going to open a new file, which is syntax, right? So I'm going to type match files equal to all, and keep only income variable and employment category. Let's confirm it. Income and employment category, right? So I'm going to highlight all this and click run selection. So now I already remove others variable and keep income variable and employment category. So in employment category is a categorical variable. If you can look at this one, it's an ordinal scale, right? We have basically three levels. One is for less than 5 years, and two is 5 years to 15 years working at that company, and three is more than 15 years, right? So what we want to know is we want to look at if the employee working less than 5 years, is the income same as person who working at between 5 to 15 years, or is also income is it same as employee who work more than 15 years, right? First, we need to know there are some assumption that you need to satisfy, you need to fulfill for one-way ANOVA. First is you need to make sure the dependent variable is numerical, right? Second one is the independent variable is categorical and more than two levels. So we already know that there is more than two levels, there is three levels. And the second thing is you need to make sure the variable are independent, right? The data sample are independent each other. There are no match or dependent sample, right? This is an independent sample, right? So the third assumption is for age group there should be a normal distribution. So how to do that? We're going to we're going to split the file, right? Compare group by employment category, right? I repeat again, split the file, choose this button, right? Split the file, compare group, right? And put employment category, group based on employment category, right? And click OK. So next, what we're going to do is to construct a box plot for each data, right? Sorry. Again, right? And click OK. So if you can see, the first group is normal distribution, but they have a lot of outlier, right? Same goes to the second group, 5 to 15 years. It's also normal distribution. And the third group is also normal distribution. There is a slightly skewed to the right distribution, but we can assume that it's normal because based on central limit theorem, if the sample size is more than 30, then we can the data set is approximately to normal distribution. So if you can look at the data for each group is more than 1000 for group number 3, 1800 for group number 3, 2300 for group number 2, and 2200 for group number 1, right? So once you're done with that, we already know that this is the normal for each group. Then you're going to unsplit the file, analyze all cases, and do not create group. Click OK. Now we're going to go to analyze, compare mean, and click on One Way ANOVA, right? So in One Way ANOVA, the dependent list is numerical, which is income, and the factor is our independent variable. And now you click on Posthoc Test and click on LSD, right? So, but before that, we need to understand one thing. In analysis of variance, right, we need to know there are another assumption that in analysis of variance. First is we need to make sure y is numerical, and independent variable is categorical with more than 2 level. And the second assumption is each group must be normally distributed. And the third assumption is there should be equal variance for each group. So to test the equality of variance, same goes to independent sample t-test. We're going to use Levin's test to test whether the variance are equal or not equal. So what we need to do is to go to analyze, compare mean, right? One way ANOVA, and input your dependent variable and independent variable. At this step, you don't need to go to Posthoc Test, right? Because we don't know whether the variance assumed or variance not assumed, right? So what we need to do is we go to option and click on homogeneity of variance and click continue and click OK. So they're going to provide you two tables. The first table is homogeneity of variance. So if you can remember, the hypothesis for homogeneity of variance, the null hypothesis is the variance are equal. The alternative hypothesis is the variance not equal, right? So if the p-value is less than 0.05, right? Let me copy this one. Oops. Let me put somewhere here. So the null hypothesis for Levin's test, null hypothesis for Levin's test, the variance are equal for right. The null alternative hypothesis, the variance are not equal for every group, or we can say that uh, at least one variance, at least one group have no equal variance. Right? If our alpha, let's say we put our alpha is 0.05, so the p-value here is equal to less than 0.001, because this is the p-value. It indicates 0.00. It doesn't mean that the p-value is 0. It means that the p-value is very small, less than 0.01. So our decision rule, if the p-value is less than 0.05, so HO is rejected, right? So since HO is rejected, so we can conclude that at least one group have unequal variance, right? So since the one group is not equal to variance, at least one group is not equal to equal variance, have no equal variance, so we cannot proceed with Posthoc test with equal variance. So if you can go to analyze again, right, compare means and click on One Way ANOVA. So we already defined dependent variable and independent variables, and now we go to Posthoc test. If the equal variance, the assumption of equality of variance assumed, then we can check LSD. But now the third assumption is not met, right? So we cannot use equal variance assume. So my advice is to go to equal variance not assume. So you can click on Danet C and click continue and click OK. Now, if you can see, there are three tables as well, right? Because the first time we already call for homogeneity of variance, right? The second table is One Way ANOVA, right? So in One Way ANOVA, the first column is sum of square. This is sum of square within group. This is sum of square within group, right? And sum of square for total. This is degree of freedom. Remember, degree of freedom for between group is number of group minus 1, 3 minus 1. And this one, number of sample size minus number of group. This is number of sample size minus 1. And mean square is sum of square between group divided by degree of freedom. And same goes to mean square for within group. Sum of square within group divided by degree of freedom. and this is F value, right? The F value is mean square between group divided by mean square within group, and this is the degree of P value. This P value shows that the P value is very small and less than 0.05. Let me copy this one first. Right. So here, let me insert this one. Right. The hypothesis for this one is H null mu group 1, which is less than 5 years. Let's say we indicate group A as less than 5 years. Group B is 5 years to 15 years, and group C is more than 15 years. Right. So let's say this is group A equal to mu mean for group B equal to mean for group C. And the null alternative hypothesis, at least one group is not equal, right? So our alpha is equal to 0.05. Let's put alpha equal to 0.05, and the P value is less than 0.001. So since P value is less than 0.05, null hypothesis is rejected, right? So since null hypothesis is rejected, so we can conclude that at least one group is not equal, right? So which group are not equal, we don't know. So until we look at the third table, which is Posthoc Test, multiple comparison using Dunnett C. So based on Dunnett C, let me copy this one, right? Right. If you can see at mean difference I minus j, there is a star after the number, right? Some result will not show any star, right? Some result will show the star, but the star indicate that the mean difference is significant, means that less than 0.05, right? Are you okay? So that, because the in post-hoc analysis, they will not provide the p-value unless you call for p-value, right? So you can see less than 5 years and compared to 5 to 15 years, there is a difference. So how many different, we don't know, but we know that there is a difference. Whether the difference is increasing or decreasing, but we can look at by mean difference. There is a increasing between 5 to 15, because the difference is the difference is negative. Mean 5 minus 5 to 15 is negative, means that there is an increasing amount of income, right? If you can see, there also a difference between less than 5 years and more than 15 years. Means that the more you work, you have more experience, the income will also increase, right? Are you okay? Right. So now look at, this is the, look at a SPSS table. So if you want to know more, you just go to One Way ANOVA and click on option and click on descriptive and click OK. It will provide same as table but with one extra table. So if you can look at less than 5 and less than 15 at the mean, less than 5 is 35,000, 5 to 15 is 54,000. There is a difference, right? How is the difference is increasing, right? Okay, so now look at example number 40. Actually, this example number 40 until example number 45, I already give you the answer in the book, right? But for this video, I'm going to show you one example, and the next example, you can do it by yourself, right? So now look at this one. A manager of a company wished to determine whether the mean times required to complete certain tasks differ for 3 levels of his trainees. So he randomly selected 5 trainees, right, from each 3 groups of trainee and assigned them with a task. So the time in days are taken to complete the task record in table number 1. So this is time number 1, number 2. So day number 1, number 2, day number 3, day number 4, day number 5. So we have 3 groups: beginner, intermediate, and advanced, right? So this is the time, 5 days. Sorry, this is not the time, right? Inside here, this is the time. Day 5, 5 days, 2 days, 3 days, 4 days, right? So now what we want to do is they are giving us table number 2, which is ANOVA, right? So we have between group and within group. Within group is the sum of square within group is 11.6. There are no given P and Q. The value of P and Q are hidden, right? RST also hidden. U is a mean of square. F is F value. So to answer this, the value of P, you cannot get the value of P if you cannot solve this one first. We need to solve this one first. You cannot get the value of P simultaneously unless you need to calculate from the scratch. So better we try to solve the easiest part. So try to calculate T. T is the degree of freedom for total. So we have basically how many sample size? This is 1, 2, 3, 4, 5. 5 multiplied with 3. Capital N should be equal to 15. So 15 minus 1 equal to 14. So this one should be equal to 14. Right? And then we can calculate for R. R is, we have 3 groups, right? So 3 minus 1 should be equal to 2, right? So then we can calculate P. P is, if you know the formula for, to get mean square for between group is 5.067 is get from P divided by R, right? So now you already know the value of R. R is equal to 2, right? So to get the value of P is equal to 5.067 multiplied with P. So this one should be equal to 10.134. This is the value of P. Now, we can calculate the value of Q, right? The Q is the total of P plus with 11.6, right? So 10.134 plus 11.6. This one should be equal to 21.734. This is the value of Q, right? So next, we can find the value of S, right, by subtracting S equal to 14 minus 2 should be equal to 12, right? Or if you cannot remember, S is also equal to N minus K, so which is 15 minus 3 is equal to 12. It's also same, right? So next we can find the value of U. U should be equal to sum of square within group divided by degree of freedom of within group. So 11.6 divided by 12. So you're going to get 0.9667. Right? This is the value of U, right? And last, we can find the value of V by taking the ratio of mean square within group divided by, mean square between group. Between group divided by mean square within group. So it's equal to 5.067 divided by 0.9667. This one should be equal to 5.2415. So we complete the first task, right? So the second one, B, based on the p-value, can you conclude that there is a significant difference in average time, right? Is there any significant difference in average time taken to complete tasks among 3 different levels of trainees, right? So the null hypothesis here is group mu for beginner is equal to mu for intermediate is also equal to mu for advanced. The alternative hypothesis, at least one group is different, right? So based on the p-value, let's put at our alpha equal to 0.05. Our p-value is 0.23, right? So since p-value is more than 0.05, HO is accepted. So we can say that, we can conclude that there this is not 0.23, basically there is 0.023, right? 23, right? 0.023, okay? So means that the p-value is less than 0.05 and HO is rejected. Right, so conclude that at least one group is different. So to know how which group is different, we need to construct a post-hoc test. So by this example, we stop at this one only, right? So for example number 41, also same as example number 40. You can do it by yourself, right? So example number 44. Yeah. Example number 44. Well, I just jumped to example number 44. So example number 42 and 43, you can do it by yourself, right? We look at example number 44. In example number 44, we need to apply some formula given in appendix, this formula, right? Appendix of your final exam question, right? So, so before we go to this formula, I just want to show you, based on example number 40, so how to key in this data into SPSS. So if you can look at our demo data set, right? We are keying the data in long format, right? We are not using format based on wide format, right? So to key in the data, let's say we go to File, New, Data, right? So you just refer to example number 40, right? So now where is my new data? New data. Oops, over here. Right. So let's say we go to a variable view first. So we need to have our dependent variable defined, which is our dependent variable is time in days, right? So we put label time in days, right? This is should be scale, and there should be no decimal point, and align center. All right, and this is group, right? So group, there are also no decimal point. The group should be nominal, and this is trainees, right? The value is 1 for beginner, 2 for intermediate, and 3 for advanced, right? So go to the data view. For time, let's say we're going to enter for beginner first. We have 5 observation. We put 5, 4, 2, 3, 4. And the second one, intermediate, we're going to have another 5. This is 3, 2, 1, 2, 4. Sorry. Right. And last one is advanced. I'm going to have another 5. This is 1, 1, 1. This is 2, 2, 2. All right. So, of course, we need to make all the assumption, right? The first assumption is why dependent variable should be numerical and independent variable should be categorical with 2 levels. Now we have more than 2 levels, 3 levels. The second one, each group should be normally distributed. But for the sake of knowledge, we're not going to we want to skip assumption number 1 and number 2 and then number 3. We just want to show you how to do analysis. The analysis is simple and same as before, in example demo data set I used before. Just go to an analysis of variance. Time is dependent, right? And group, let's choose LSD, and descriptive here, homogeneity of variance, and click OK. Right. So we're going to get the same result as given in example number 40, right? So now we focus on example number 41, example number 44. So in example number 44, right, there are three groups as well, right? A bakery shop in Shah Alam decide to test the new recipe for its chocolate cake. The chef decided to use three different type of flour to bake the cake. He assumed that there is a difference in taste of the chocolate cake. Right? The sales for slice of cake for different type of flour is recorded in table number 7. So we have flour A, flour A, B, flour C. Right? So the SPSS output. So before we proceed, what is the N here? N it should be this one: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 15. So we have 15. Right? So the SPSS output in table number 8, right? So the significant value is 0.003, which is there is at least one group is different. It's one floor is different. So complete the ANOVA table, right? So as usual, we start with the simplest one. So we try to go to I equal to degree of freedom for between group. So between group is k minus 1, which is equal to 2. 3 group minus 1 equal to 2, right? And this ANOVA table is quite hard to get from simple calculation because there are no clue given for mean square and sum of square. But never mind, we can try one by one. K, and then we go to J. J should be equal to n minus k. 15 minus 3 should be equal to 12. Right? Next, we want to find, let's say we want to find G, which is sum of square between group, right? Sum of square between group, or in other way we can call it a sum of square treatment group, right? So based on this one, right, this formula, so T is sum of square in sample, right? Sum of square in sample, right? Okay, T1 square divided by N1, T2 square divided by N2, T3 square divided by N3, and so on. And minus with summation of x, then is squared divided by N. So let me copy this formula, right? So we can, wait. So I cannot copy this one, right? I just want to copy like this. Okay. Oops. Now, the T1 is equal to the sum for the sample for group number 1, treatment number 1. So this one, T1 should be equal to 25 plus 38 plus 42 plus 65 plus 47 plus 52. There are 1, 2, 3, 4, 5, 6. So T1 should be equal to 269. It should be equal to 269. So let me calculate this one first. Where is my calculator? Right. And for T2 should be equal to 15 plus 21 plus 19 plus 25. It should be equal to 80, right? And T3 should be equal to 44 plus 39 plus 54 plus 58 plus 73 should be equal to 268. Right? Okay. So based on this formula, what we want to find is G. So G should be equal to 269 is T power of 2 divided by our sample size for group number 1 is, how many sample we have? This one, N1 equal to 6, N2 equal to 4, N3 equal to 5, right? This one should be equal to 6 plus 80 power of 2 divided by 4 plus 268 power of 2 divided by 5. So this is the first part for sum of square between group. And we need to minus with sum of square, sum of x. Sum of x is actually equal to the total. Sum of x is equal to T1 plus T2 plus T3 should be equal to 269 plus 80 plus 268. This one should be equal to 617. So 617 power of 2 divided by n. Our n is equal to 15. The total n. Right? So we're going to get the sum of square between group. This one should be equal to 2645.7. Right? You should put it in G. So to get H, so G should be equal to 2645.7. And then H is equal to 4309.733 minus 2645.7. This one should be equal to 1664.033. Right? So now it's become easier for us to find K. K should be equal to G divided by I. So our G is equal to 2645.7 divided by I equal to 2. So this one should be equal to 1322.85. Right? And L should be equal to H divided by J, which is 1664.033 divided by J is equal to 12, should be equal to 138.9. 0.6694. And M should be equal to the ratio of K and L, right? It should be 1322.85 divided by 138.6694, and then M should be equal to 9.5396. That's all, right? So the next question is easy to answer. How many observations involve n minus 1? So n minus 1 is equal to 15 minus 1 equal to 14. Sorry, this is the degree of freedom. So how many observations involved? It's straightforward, 15, right? And state the null hypothesis. So null hypothesis is very easy. H null mu1 equal to mu2 equal to mu3. H alternative. So of course you need to put mu for FLA A, right? FA, FB, FC. At least one group are different, right? Based on the p-value, what can you conclude from the Chef claim? At alpha 0.03, so p-value is 0.003, which is less than 0.03. So we can conclude that H null is rejected, right? So at least one group is different, right? So I think that's all. You can do past year question June 2018 on question number 5, and you can also explore another question in past year question, right? Make sure you do example number 41, 42, 43, and 45. Right? Okay, thank you very much and good luck.